Okay, in this example, we're going to be doing a lot of integer and binary program with a lot of different variables. So let's just jump right into it. So the green grass company manufactures and distributes fertilizer. The company sells its product to high volume customers in various U.S. cities where it has manufacturing plants, but it can decide to operate only some of the plants in any given month. Fixed monthly costs are $60K, operating costs are $10.25 a pound, and shipping costs are 2 cents per pound per mile. So in the next page, where we have got a lot of this information, all customer orders do not need to be filled, and for the current month, Graingrass must decide which plants to operate and which customers to service from which plants to maximize profit. So let's go to the next page and take a look at what information we've been given. So here is the initial information that was given in the problem: 10 1/4 production per pound, 2 cents per mile per pound, 60,000 fixed cost, and our plant capacity, which wasn't given in the problem, we can only make 2,500 pounds. And so we have plants in Boston, Chicago, Dallas, Denver, LA, Miami, New York, and Phoenix. So up here is our distance matrix, and that's just showing us the distance between any two cities, because we're going to need that for our shipping charges. And then over here we have the current orders that have come in. Now we don't have to fill all of these, but we want to fill as many as we can to maximize our profit. And since that's going to be based on shipping cost and production cost, this one's going to be pretty important. And so what we're going to do is we need to figure out which plants to open, which customers to service, and from what plants are they going to be serviced by. Now, as we're doing this, we've got the caveat that each plant can only service one customer, but that does not mean that we can't have multiple plants servicing a customer. So let's say that we decide that we're going to service Boston, and then we're sending product from both Boston and New York. So the Boston plant will send to Boston, and the New York plant will send to Boston. So we're going to have to start putting all of that stuff together. Okay, so this one seems kind of large, but let's just piece it together and get things going. So the first thing is, let's take a look at how I've got the sheet set up. So I've got this right here for the open plant. This would be our binary variable, because this is, just remember, binary is a logical choice. And so 1 if the plant's open, 0 if the plant's closed. And then here we're going to have another binary variable. So we have along the side which customers we have, and along the top we have which plants are servicing each customer. And so the number serviced by has to be less than 1. Actually, just type these in. I didn't have that recorded, but we're only allowed to each thing can only be serviced by one plant. And then down here, so this is going to be another binary variable, because it's a 1 or 0. It's either it's being serviced or it's not. I have right here a matrix in monetary output. So this is going to be my revenue minus my production and my shipping cost for each customer. So the customers are along the side, being shipped from the plant along the top. This matrix this one will be a little bit more complex to put together, but it's still not that bad. And this is not called the contribution margin or anything, because I have the fixed cost broken out here. And then we're going to go right to total monthly profit, which is what we're trying to calculate. So as we start going and building out our constraints and everything, let's go and write those over here just so we know what's going on. So our objective in this is to maximize profit. That's fairly simple. And then our decision variables are what plant are we going to open, and then what customers are we going to ship to. And then finally, we have our constraints. So one of our constraints is we can only service one city per plant. And we do have a capacity constraint. Our factories can only each produce 2,500 pounds of material. So if we go and we look at that, that's all we've got with the problem. Doesn't seem like a lot, but it's just we have to start adding the stuff together. Alright, so we are going to, let's grab our range name. So we know what our two constraints are. It's going to be the number serviced by and the allowed. So we'll make those range names. Go into formulas, create from selection, top row. And we also know our capacity is going to be a constraint. So I'll highlight that, hold control, pick the next one, create from selection, left column. And let's go grab our objective. Oops. Create from selection, left column. And then I have all these matrices and everything here, so I'm not going to need any of that. Let's see. We can make those range names too, because we're going to have some equations that we're not going to want them to move. And then these ones here we'll just leave. So that should be fine for what we need. We'll just come over here, range names, control B to bold, use in formula, paste names, paste list. And just get them over there just so we have them on the sheet. Okay, so the first thing that we do is we want the different plants. And so we're just going to sit there and we're going to sum up everything. So the customer can only be serviced by one plant. And so then we'll drag that down. We'll take care of that. So the customers can only be serviced by one plant, but we can ship out product to everybody. So Boston could ship it to Boston and New York. And so how are we going to do that? Well, we're going to have to figure out how many pounds of this that we're going to ship out. So here's my order quantity here, Boston to Phoenix. Here are my customers, Boston to Phoenix. So let's look at how we would do that. Well, we could do a sum product of whichever plant is servicing the city with the quantity. Oh, gotta hold control. Actually, that, there we go. Now, we did not give this a range name, so we got to make sure to lock that in. So I'm just going to go to that L11 to 18. I'm going to put my dollar signs in so that will not move. So what I'm going to do is I want to drag this over. So if I pick this one here, so what I have is plant along the top. So this is LA. And so whichever orders that we're deciding to fill out of the LA plant, those will sum all up. So we could grab like LA, Miami, those two together is 1,500. They'd be able to ship to two different places. And as long as we're under that 2,500 pounds, we are good. So that's our logical capacity. So we're going to have to say that this, whatever pounds that we ship out of Boston, is going to have to be less than or equal to our capacity. Now, I can just put 2,500 in, but that's not going to work out so well, because if I leave this in, so I drag this over, these are all 2,500, remember that Excel, without this capacity constraint, get kind of confused, because what's going to happen is this opening plant's only going to give us a fixed charge. And Therefore, if we have a fixed charge, Excel's going to put zeros in all of it because, well, fixed charge is going to cost me money. Why open any of those plants? So we have to tie whether or not we open this plant down here to whether or not the plant's going to be able to produce anything. And so the way that we do that is we'll just take that capacity and we'll multiply that by whether or not the plant's open. And there we go. So now if I drag that over, these are now all 0 because if the plant's not open, we don't want it to be able to do any of the calculations here. So if I put a 1 in Denver's open, that changes the constraint here to 2,500 pounds. So now Excel goes, okay, well, these are valid cells to fill in. And I forgot to, let's go put over our here, that 1 has got to be less than or equal to 0. Okay, so once again, quickly to explain what's going on here. These are the customers along the side. These are the factories where we're shipping out product. The key thing from the problem is that the cities can only be serviced by one factory. So factories can service multiple cities, but each city can only take it from one. And so I sum up here to make sure that Boston's only being serviced by one of these factories. That's why the less than or equal to 1 is there, because Boston doesn't have to be serviced. If it had to be serviced, if we had to fill every city, then that would have to be an equal to make sure that every city got filled. But since we do have that caveat, we don't have to fill all the orders. We're using less than or equal to 1. And so down here is going to be the amount of product shipped out. So let's say that Boston is going to ship to only Boston, and we open the Boston factory, then you're going to see that, hey, we've got 1,430 pounds. That's less than the 2,500. Let's say Boston also fills the Miami order. And so there we go. So Boston is producing fertilizer for 2 different places, Boston and New York, or excuse me, Boston and Miami. That adds up to 2260, which is less than the 2,500. So down here, these constraints along the columns are our production capacities. The ones across the row are the number of cities we're being serviced. Okay, so with that, we're going to take a pause here. In the next video, we'll put together the monetary outputs matrix.